Hi guys, welcome to another episode. In this episode, we will focus on collisions. We want to be sure that the move that user is trying to make is not only valid as it would be on an empty board, but it's also valid within a context. So the first thing I would like to change is this index PHP. Here we have perform action, and this is okay. And as we talked at the very early stage of this project, this index is responsible for communication with user to display information, to get information from user about the move, and so on. But as you can see here, we take information, some details about the move, we do validation, and if it's correct, then we do movement. I would like to move this stuff to the engine itself, because those actions should be done regardless from where the information about the move comes from the console, from the web application, or from any other API. Yes, so that's where we start our refactoring. So let's start with the engine, and let's move this code. I will keep it index here as well, but let's create a new method. And do some refactoring. Yeah, it's not game anymore because it's a simple method. Let's simplify this one. Okay, let's simplify this one as well. And we don't want to have any nested if statement, so if it's not move, and we return no. Okay. We can call this as self. It's a move. It's a move. And this is this. And we want to return our move. The same as we did it previously here, right? So this one is more or less done. Here we go. Here we are going to remove this. I mean, replace by simple move. There are no details anymore. And we want just a simple message. This section we don't need anymore. If not move. Then if move is correct, let's move it. If it's not, we'll just display invalid move. Okay, so let's start our application. Let's see A2 to A4 is correct. C2 to C5 incorrect. Move wasn't performed, but we cannot see error message. But let's see C2 C5 is invalid move, yeah, because we didn't add semicolon colon between those coordinates. We lost some messages for end users, but we will fix it in a second. But more or less, it works. So now we can continue working on our collision system, and collision is a part of the figure movement, right? So we can think about few different kind of moves. It's like a standard move. It's like attack. It's illegal, but because something is is in the way, it can be like something like, let's say, friendly fire, right? If we want to move our figure to a location where our figure is already, and it can be simply illegal for many different reasons. Maybe it's occupied, but like a pawn cannot attack front, it has to attack in this V shape. Yeah, so it can be simply illegal. And we can use some enums, but we can also use constants. Let me paste them here. And those constants are a good practice, because later in the code, first of all, every editor will help you suggesting those values. You avoid meaningless numbers, because later on, if we compare if this collision is equals to 1 or equals to 2, it doesn't say anything, right? But if you see that we compare move attack, it's self-explanatory. So that's why it is a good practice to to use some kind of enums in whatever way you use it, but avoid using simple integer values. So the next thing is to add our collision detection system. And a very good practice is to think about complexity of every step. Here we have our move details. You just grab some information about the move. Here we do very simple validation, which is very simple, and it's not very expensive for the CPU. But of course, it's not the end of the story. So now we are gradually increasing complexity of our checks. So we will nest our collision inside of this if statement, because it doesn't make sense to check collision if the move is not valid at all. Make like this: collision equals to this, and we need collisions, right? We don't have this method right now, so I'm going to implement it. So this is very basic collisions method. We pass move, even we don't use it right now, and the default return is that the move is unknown, right? And we return integer as we defined all our constants as integers, yeah, but we return integer value which is behind. Having this done, we can add this value because we return move to our front end, so we can go here to our chest move and add one more property, which is collision. And here in our engine we can do move collision equals to collision. Now we know that only value we return is this unknown value. So we can go here and we know that we can return values already. So if we return move, it can be illegal, legal, friendly fire, but still it will be a defined move. We can make a check, yeah? So move collision equals chess engine unknown. One more tiny improvement just to avoid having tons of return statements. So we can have a one string which is empty by default, and this, and we return our message. So we have our move. If the move is unknown, we display this message to, we return this message to the user interface. Like here, if the move is completely unknown, like for example my string wasn't recognized as a move, we display this very message. So let's go back to our move, because this is a rather unusual situation, right? That we will have just unknown move. So now we need to check, and the same as we did for this validation. Here we have our first snippet. Here we calculate start and end. As you can see, we calculate rows multiplying by 8, adding a column here as well, and you may wonder why. If you go to our board, how we define this, it is a one-dimensional array. We have it in our code in rows and columns, but for PHP it is a one long array. So that's why we have 8 elements for every row, but for PHP it is one-dimensional 64 elements array. Yeah, so that's why we have here, and because we display it from the bottom. Number 1 is at the bottom, number 8 is on the top, but for PHP it is opposite, so that's why we have to revert our start and end position. That's why we have only 2 values, not 4. We don't have XY on the top and XY at the bottom, because we just need a start and end position. That implies things like this. which means that step, if the column from and the column to are the same, it means that we will have to jump 8 elements in our array. That's exactly what this condition checks. We calculate the step, and if we should go forward or backward. Here we have already defined our player 1. It is this condition to know who made this move, and we check if it's not the player 1, and this is the threshold where we define small letters and capital letters. Yeah, or if the player is 1 and the figure that we found in this position where we are going to is less than 97, we are doing friendly fire, because we would like to go and we would like to attack a place where our other figure already is. If there's some other figure, this is our roadblock, right? Because we cannot attack doing this movement. And the same is here, but it is in a reverse mode. It can be optimized, but that's not critical for now. And finally, if the destination figure is an empty space, like here, yeah, so it means that this nothing's there. So we return a standard move, and everything is fine. Another figure is our knight. This figure is way simpler, right? If the destination location is empty, it's a standard move, it's not an attack, so it's fine. And we do the same check as above. Yeah, if the figure 2 is our, so we use a friendly fire, but if it's not, we do attack. So we have actually 3 different possible returns. And the next figure on our list is our bishop, and that symbol represents how it moves. This calculation, the start and end point, is exactly the same as common for all elements, and this condition may look weird, but let's take a look on our board. So here we have our board. This is our bishop, and remember that here we have points 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. So if we have our bishop here, and we would like to move this direction, yeah, that's how bishop moves, what we need to do? First of all, we need to figure out if the start is greater than end. Yeah, so this is like a 59, let's say, and this will be like more or less 40. Yeah, so we know that the end is greater, is smaller than this one, right? So that's why we go to this condition. And next question is if the from column is bigger than to column. In this case, it's not, because we are going from C to B, which means that the distance between those two elements on a one-dimensional array is 1, 2, 3, 4, 5, 6, 7, 8, 9 elements. That's why we have 9. If you would like to go this direction, which means that D is bigger than C, yeah, so from column would be smaller than to column, we use value 7. Yeah, so it's 1, 2, 3, 4, 5, 6, 7. So that's our step. And distance between those two black fields is also 7. 7, 7, and so on. That's why we have to calculate the step. We have a step, we go through the board. If it's empty field, we can occupy. If it's not, we determine if it's our figure or it's opponent's figure. If it's our, we return friendly fire. If it's not, we can return roadblock. Roadblock means that there is some other figure in our way before we reach our destination. If we do not return anything here, we have this condition, because our final destination, so not the figure that is on this location, but the final one, if it's if equals to empty space, return standard. It's a standard move. But at the very end of our road, there can be also our figure, so we return friendly fire. But if there's an opponent's figure, we can attack